a natural source like your sun, specifically in sun or in any other stellar objects. So actually light is getting converted from that thing. Your nuclear fusion reaction is there, and after that, in that process, a large amount of heat energy is released, and after that we are getting light. Heat is getting converted into light. So here nuclear fusion in sun, some fusion reaction is going on. So in your atoms in nuclear chapter you learn there are two types of nuclear reactions. One is called fusion and one is called fission. And fusion here it means union, and two lighter nuclei combine to make a heavier nuclei. So that type of reaction is called your fusion reaction. So in that reaction some huge amount of energy is released in the form of heat, and that thing is again getting converted into light. So as for example, I am telling you one form of fusion reaction in particular which is happening in your sun or in other stellar objects. So lighter nuclei like hydrogen, so two hydrogen atoms combine to form helium. So this is how the conversion is going on. Two lighter nuclei, like why this is lighter, because we know the masses of hydrogen is less than the atomic mass of helium. So that's why they are lighter nuclei and helium is heavier nuclei. So two lighter nuclei like hydrogen are combining to make your helium nuclei. So that's why this is called fusion reaction, and during this reaction some huge amount of energy in the form of heat is released, and a part of that heat is then again converted into light. So if we balance that reaction, so hydrogen atomic number is 1, we know 1 1, but it's 2 4. Helium atomic number is 2, atomic mass is 4. So here you may ask that, sir, atomic why 2 is there? So we know there are 3 isotopes of hydrogen. One is called protium, one is called deuterium, and one is called tritium. So in deuterium your mass number is 2, and in tritium your mass number is 3, and in protium your mass number is 1. So 2, that means we are considering the deuterium isotope of hydrogen. So here we have 1 electron and 1 neutron. That's why the mass number is there is 1 proton and 1 neutron. That's why the atomic mass becomes 2. Okay, so it is a one isotope of hydrogen. Okay, there are 3 isotopes of hydrogen. I just told you. If we consider isotopes of hydrogen atom, so there is hydrogen 1 1, hydrogen 1 2, and hydrogen 1 3. So here it is called protium, it is called deuterium, it is called tritium. So here your in all the cases your atomic number is same. So this is the very definition of your isotope. So atoms of this, these are the atoms of the same element having same number of electrons or protons, because number of electrons and number of protons are same, but different number of neutrons, because that neutron number is different. In protium there is no neutron, because number of electron and number of proton must be same. So if it is atomic number, that is number of electrons, and the proton must be equal. So 1 proton is there. Here in your deuterium your atomic number is again 1, that means your 1 proton is there, but there is 1 more neutron. That's why the atomic mass become 2. And in tritium your atomic atomic number is 1, that is your number of proton is 1 again, but there are 2 number of neutrons. So here there is no neutron, here there is 1 neutron, here there is 2 neutron. So that's why these are the different isotopes. So these are the atoms of the same element Having same atomic number and different mass number, you can tell. So this is one way of defining your isotope. Another is these are the atoms of the same element having same number of protons. In all the cases, number of protons and number of electrons are same, but different number of neutrons. Because here there is no neutron, 0 neutron is there, here 1 neutron is there, and 2 neutron is there. 2 plus 1 is 3, 1 plus 1 is 2, and 0 and 1 electron is there, so the 1 proton is there, so this atomic mass is 1. So I've considered the deuterium isotope of hydrogen atom. So since the atomic mass is less than the helium, that's why it is called lighter nuclei, and here it is called heavier nuclei. Okay, so 2 lighter nuclei combine to form heavier nuclei, and along with that some huge amount of energy is released in the form of heat, and that heat is again, a part of that heat energy is getting converted into light. So that's how we get light from in your natural source like your sun. So in artificial source, now coming back to artificial source like your earthen lamp, suppose. So one example was there in your artificial source case. So earthen lamp is there. So earthen lamp, here chemical energy both in earthen lamp and candle fire, both the cases you can relate the same thing. Here chemical energy is getting converted into heat energy, and then it is getting converted into light. So this is how energy is getting converted. Okay, all of a sudden we are not getting light, it must have converted from some other form of energy. So like here from nuclear fission reaction to from heat energy to heat energy to light energy, here from chemical energy to heat energy to light energy. So, and in third case, suppose in your electric bulb, this is again your artificial source case. Here also from electrical energy, yes, how we get light in electric bulb, because we first switch on the your board in the we just switch on the board. That means we are giving some electric energy, then it is getting converted into heat energy, and then it is getting converted into light energy. So heat energy to light energy. So it is not true for all the recent electric bulbs. So I am talking particularly the electric bulb which was first invented by your Thomas Alva Edison in the year 1879, I think, yes, 1879. So the earlier one, the earlier form of electric bulb where we use filament, okay, and the form of the electric bulb is something like that. So let me erase. So let me tell you that thing again. So not in all case of form of electric bulb the process of conversion of energy is like that. There is electric energy to heat energy to light energy. So I am specifically telling about your the old form of electric bulb actually. So which was something like that. And we use some filament there, okay. That filament is made of tungsten metal. It's having very high melting point. So when we switch on the circuit, they switch on the board. So that means we are giving some electric energy. So current is flowing through the bulb. That electric energy is now going to that particular circuit, and the tungsten metal is now heated. So now when sufficient amount of sufficient amount of temperature is raised, now then so first your heat energy will be, there will be some heat energy, and then from heat energy we will get light. So first it is heated actually, that tungsten metal is heated, and after that when sufficient temperature is raised, now from heat we will get light. That's how the process of conversion of energy takes place in your electric bulb. There is earlier form of electric bulb, okay, so which was invented by your Thomas Alva Edison. So electric energy is now converted to heat energy because filament is heated, and when sufficient amount of temperature is raised, that heat energy is converted into light energy. So actually I was just discussing what is the process of conversion of energy in the different sources of light. So this is how the light is getting converted in all these sources. So now you know what is optics. So this is a branch of physics that deals with the nature of light, its sources, properties and effects. Also you know what are the two categories of optics. This what are how optics is divided. It is again divided into, that means we have seen that it is divided into your physical optics and geometrical optics. And physical optics deals with the wave nature of light, and wave ray optics or geometrical optics deals with those bodies of light which can be easily described with straight line and plane geometry. So we have also learned what is light and how we are getting light actually from different sources of light. So how the energy is converted, how light energy is converted from different sources, from other forms of energy, we have just seen. So after that, in light, in optics we will learn there is something called ray of light, because we never when we speak about light, first thing that comes in our mind is something called ray of light. So light, we speak of light in the form of ray. There is something called ray of light. So what is the definition of ray of light? So the path of propagation of light is called a ray. So the path of propagation of light is called ray. So light travels in some path, and that path of propagation is called a ray of light. Okay, so suppose light is traveling in that path. So, and if you give actually a ray is always indicated, it is indicated with a straight line with an arrowhead. So that's how a ray of light is indicated. So always indicated by a straight line. By a straight line with an arrowhead. So, and what does the arrow indicates actually? The arrow indicates the path of the direction of so this is actually what arrow indicates. So the path of propagation of light is called a ray, and it is always indicated by a straight line with an arrowhead. So here I have indicated that light is traveling in this direction, because ray of light is always indicated by a straight line with an arrowhead, and that arrow indicates the direction of propagation, in which direction your light is going. So if I draw the ray of light in that direction, that means light is going in that direction. So this is always, light will be indicated by a ray. A ray means a straight line with an arrowhead. Ray means nothing but your path of propagation of light, where in which path your light is going, and it is indicated by a straight line with an arrow. Arrow will tell you in which direction it is going. So these are the two rays of light you can say, and in that particular ray light is coming in that direction, and in that particular ray light is going in that direction. So that arrow will indicate in which direction the light will go. So this is all about your ray of light. So it is nothing but the path of propagation of light. So in which path your light is going. Okay. After that, something comes called beam of light. So you know light, now you know what is a ray of light. Now what is called beam of light, a beam or a beam of light. So actually we never speak of light in the form of a ray. We always speak of light in the form of beam. A beam of light is coming, a beam of light is going in that direction. So actually beam of light always comes. So what does it mean? So it means a bundle of rays. So rays in bundle. A bundle of rays is called a beam. Light will never come in one single ray. It will always come in a bundle of rays. Okay, and that bundle of rays is called a beam of light. So a beam can be, beam is again divided into three categories. A beam can be your parallel, so there can be a parallel beam of light. A beam can be your convergent, and a beam can be your divergent. So beam can be a parallel beam of light, it can be convergent beam, and it's a divergent beam. So we know that bundle of rays is called a beam. So in parallel beam of light, what will happen? All the rays which forms the beam, they will be in parallel. Okay, so like that, either like that or in this direction or in that direction, any way. So because arrow will indicate the direction of propagation of light. So either light is going in that direction or in that direction or in any other direction. But the main thing is that all the rays which forms the beam, they are parallel. Parallel, you know, the distance between any two particular ray will be same. It will not change. Okay, for any two particular ray you consider, the distance will always remain same. So this is an example of your parallel beam of light. Convergent. What do you mean by convergent beam of light then? So if the rays meet at a point, if all these rays which form a beam, if they meet at a particular point, so that particular beam is called a convergent beam. Because beam, why it is beam? Because it is a bundle of ray. But in that particular bundle, in particular beam, all the rays are actually, you can see that they actually meet at a certain point. So they will meet at a certain point. So if this is the case, then we say that that particular beam is called convergent. It means if the rays which forms the beam, if they meet at a particular point, then that particular beam is called a convergent beam. So now what is divergent beam then? Okay, so let me erase that thing first. So in case of divergent beam, so here the rays will diverge from a particular point. Okay, suppose one point is there, suppose the ray is coming out, or actually we say that rays are diverging from this particular point. So you can say that all these rays are coming from this point. They are not meeting actually. They are actually going out. All the rays are going out or coming out from this particular point. Then they are called divergent, because they will never meet in future. If you go on extending these rays, they will never meet in their path. But because they have actually come out from a particular point. But in case of convergent beam, we have seen that they are actually meeting. They are actually meeting at a particular point. they have started their journey at some previous point of time, but after some time they will meet at a particular point. Here they have started their journey from here, all these rays, but they will never meet in future. And that kind of rays or beam, because the bundle of rays is called beam, and that beam is called a divergent beam. Means in divergent beam the rays will never meet, and they actually come out or extend out from a particular point. And in convergent beam the rays actually meet at a particular point, and in parallel beam all the rays, they will remain parallel. Okay. Example I will give you. Okay, I will give you what are the examples of divergent beam, where we can see the divergent beam and where you can see your convergent beam. I will give you example. But for the time being I am telling you where you can see your parallel beam. Okay, so because I have to teach you something called your mirror. Okay, before that your spherical mirror, like your convex mirror and concave mirror. In that case, in concave mirror specifically, we'll see the case of that convergent beam, and in convex mirror is also called diverging mirror, we'll see the case of your divergent beam. Okay, so before that I have to teach you that thing, so that's why I'm not giving you that example here. So now for the time being I'm telling you where we can see your parallel beam of light. So suppose in sun, rays which are coming from sun, or beam which are coming from sun, because we know that sun is situated in infinity, sun or any other stellar object which are situated from infinity, and from infinity the rays which are proceeding there, we consider them as parallel. So this is the case of your parallel beam. If anyone asks you where you can see your parallel beam of light, so that will be your answer. So rays which are coming from sun, these are the parallel beams. A beam which is coming from sun, this is an example of parallel beam of light, because here all the rays which forms the beam, they are parallel. Okay, so I think let me stop here for today, because the class is going long. And before stopping, let me tell you another important aspect of light, you can say that. So light is a form of energy, there is nothing wrong is there. So light is a form of energy, but light is an electromagnetic wave, because in physical optics we know that in that branch of optics it deals with the wave nature of light. So light is a wave. So light is actually an electromagnetic wave. That thing I want to tell you actually. Light is an electromagnetic wave. Because what kind of wave? So it is actually an electromagnetic wave. So because in optics we study all these things. What are the different nature of light? So what it is wave nature, what it is particle nature, anything, what it is properties, what it is sources. So actually light is in wave also. If you are saying that light is a wave, then what kind of wave? Then it is actually electromagnetic wave. Okay, there is something called mechanical wave, we know, sound wave is there, and electromagnetic wave. Light is actually an electromagnetic wave. So that means in light both kind of we will learn that both kind of fields are there, one electric field and magnetic field, they are coupled together and they together flow. Okay, so that's why light is called an electromagnetic wave. Okay, we will learn that things in details in your electromagnetic wave chapter. Okay, so right now for the time being just remember that light is an electromagnetic wave, and there is something electromagnetic spectrum. Okay, if we classify all the electromagnetic waves, light is actually a form of electromagnetic wave. Other electromagnetic waves are also there, like your, so these are the classifications of, or you can say that it is a electromagnetic spectrum I'm going to write. So there is something radio wave, there is something called your microwave, there is something your infrared, wave, then your visible light. then comes your ultraviolet, then your X-rays, then your gamma rays. So these are the different classifications of electromagnetic wave, or we also said that this is a electromagnetic spectrum. Electromagnetic spectrum. So here your visible light, that thing actually your comprises of your light. We are saying about light everywhere, so that visible light is actually that light, what it means. So it is a part of your electromagnetic wave. So this is your electromagnetic spectrum, and visible light forms a part of it. So actually how I have written all these things, actually I have classified all these things based on some parameter, you can say, or some or dimension, and that thing is called your wavelength. So I have written all these things in terms of your decreasing wavelength. So here from top to bottom your wavelength is actually decreasing. So from going from top to bottom, if you go from top to bottom, your wavelength is, that is lambda, is actually decreasing. There is the wavelength of radio wave is greater than the wavelength of microwave, and the wavelength of microwave is greater than the infrared, and it is greater than the visible n. So that maximum wavelength is for radio wave, and the minimum wavelength is for gamma rays. So if we invert that thing, we know that wavelength is decreasing, that means your from top to bottom. Then you can also say that your frequency is increasing, because wavelength is reciprocal to your frequency, we know, because if you go by that relation, c is equal to nu lambda, okay, velocity is equal to wavelength into frequency. C is the suppose speed of light, c is the speed of light, so it is constant, so nu is equal to c by lambda. So this is the reciprocal relation because it is constant. So it is nu is, you can say that nu is inversely proportional to lambda. So if lambda increases, then your nu, that is frequency, will decrease. Okay, because c is constant here. So if lambda increases, then nu will decrease. So that's why you can say that your where your lambda is decreasing, your nu is actually increasing. Okay, so that means if we say in terms of frequency, so your frequency is increasing if you go from top to bottom. Okay, and gamma rays are having the maximum frequency, and radio waves are having the minimum frequency wavelength. So actually, and light is a visible light is a part of that electromagnetic spectrum or electromagnetic wave classification. So it extends from a wavelength of 400 to 700 nanometer. So visible light actually extends from a wavelength of, so it is there for every particular wave or category, there is some wavelength. I am writing specifically for your visible light because it is a very important one mark question. Sometimes it comes, what is the wavelength range of visible light? Because light is called visible light. When we are saying about light, that means it is visible light. Okay, the visible light. So and then what is the wavelength range of visible light? So that is particularly the wavelength range 400 to 700 nanometer. Okay, earlier we have seen that how light is converted, and so in again we know that in physical optics we studied the wave nature of light. So what kind of wave actually it is? So it is an electromagnetic wave. Okay, so and which comprises of these different classes of waves, you can say, and visible light forms a part of it, and which extends from wavelength range of 400 to 700 nanometer. So this is all about your light. Okay, so in next chapter or in next class, hopefully we'll start with the next topic, like your reflection and refraction. Okay, and for today this is all. Okay, thank you.